Hello students, welcome to this module number 4. We are going to discuss about numericals on the pure substance chapter. While using this problem, we have to use steam table. Okay, and what is the problem is given and how we are going to solve, we will look over it. Okay, so problem is like this. A steam at 8.5 bar and 0.95 dryness fraction is expanded to 1.5 atmosphere. Find the condition of the steam for each of the following. First one is the throttling, second one is reversible adiabatic. Okay, so here at these two conditions we are going to supposed to find out the values in the from the steam table. Okay, see, for this problem, we are taking the values from the steam table that at 8.5 bar. So, what are the properties of the steam? HF1 we can note it down as 734.4 and HFG1 2037.7 and saturation temperature is 173.5. Okay, so for the 0.95 dry, so this is the property, that is SF1 also a 2.067 kilojoules per kg Kelvin. And another side and it is expanded to 1.5 bar. Again the property we can look over here, that is HF2 is 467.1 and HFG2 226.5 and saturation temperature is 111.4 degrees centigrade. So these are the properties, and SF2 is also we can find that is 1.434 kilojoules per kg Kelvin. So while calculating the throttling process, already you know that throttling is nothing but the enthalpy remains same before and after, very simple. So this enthalpy before expansion and enthalpy after the expansion, we can write it as H1 is equal to H2. What is the H1 of the first state? That is HF1 plus X1 into HFG1 is equal to HF2 plus X2 into HFG2. So we have this relation for finding this enthalpy, but there is no such change from dryness fraction from beginning at the and final. So here there is a property like x1, we know that is 0.95, but we don't know what is the enthalpy, that is the dryness fraction after the throttling. So that we have to find out. Substituting these values, that is HF1 as 734.4 and x1 is already, we know that in the given the problem, that is 0.95, and HFG1 corresponding that 8 bar, that is 2033.7 kilojoules per kg and equals to 467.1, that is HF2, and X2 we don't know, that we have to find out, and HFG2 is 2226.5 kilojoules per kg. After substitution of this and calculating this value, so it becomes how much, that is 0.98. 0.98. Okay, so that value we can observe here, 0.98. What is that value? That is a dryness fraction of the steam after the throttling. So initially at a particular pressure it is going to be expanded. Okay, the steam is going to be expanded through the throttling and it becomes 0.95 to 0.98. So means that there is a possibility of making this process to make the improve in the quality of the steam. So whatever the moisture will be there, that will be converted into it becomes dry. So that is 0.95 to 0.98. So that is one thing we can conclude from this concept. And second one is, they asked if the same steam is done under reversible adiabatic process. Earlier it was for the throttling process. If it is happens in reversible adiabatic process, what will be the quality of the steam? That we have to find out. See, there is a changes based on the process. Okay, we have already know that in the throttling process there is a enthalpy remains same before and after. While come to this reversible adiabatic process, entropy remains same before expansion and after the expansion. That you keep it in mind. That is S1 is equal to S2. So S1 is what? That is we can write easily SF1 plus X1 into HFG1. Okay. So this is the formula, or you can write it as, instead of writing HFG1 by T1, we can write it as SFG2. Okay. So HFG1 we can write it, but we don't have SFG2 directly. So corresponding the value which we have in terms of HFG1, so that we can write it. Okay, and is equals to SF2 plus X2 into HFG2 by T2. Okay, this is the value. Then now you are going to supposed to substitute these values in the equations. That is 2.067 plus 0.95, it is already given the problem, into HFG1, that is 2037.7, and temperature is given, that is we have to consider in terms of absolute temperature. That's what we are adding here, 273 value, because 173.5 degrees centigrade is there. So we have to add up this 273 because it is an absolute temperature. That is one thing we have to remember. And is equals to 1.434. This is for SF2. Okay, the corresponding that pressure, what pressure it is, that we know that from 1.5 atmospheric pressure. This is for this 1.5 atmospheric pressure. We already noted these values that we are writing now. Okay, so please just look over this all the values. Okay, next one is HFG2. Already we know that 2026.5 divided by 111.4, and along with the 273 we have to add up, so that because it is absolute temperature. Then once if you substituting all the properties of steam in this equation, so unknown is that is X2. Okay, this value we have to find out, X2 value. Okay, so after substitute and calculating this value, we may get the X2 becomes 0.86. Okay, 0.86. So from this problem, what we understood that there is a change in process. The process also, it may be where is the dryness fraction, because as you see in the previous process, it is an enthalpy, constant enthalpy process, or we call it as throttling process. There is a change in dryness fraction or improvement in dryness fraction. Okay, so but here, well, it is very reverse, because as it is in enthalpy process, there is slight improvement in the quality of dryness fraction. But here, due to this entropy process, reversible adiabatic process, the dryness fraction becomes 0.86, from 0.95 to 0.86. That is the main observation in this problem. I hope you understood how the problem is going to be solved and understand this concept. So as changes in the process, it may be effect on the dryness fraction. So while taking this enthalpy process, we are considering H1 is equal to H2, and this the quality of the steam is going to be improved. But whereas in case of entropy, the quality of the steam is 0.95. After entropy process or reversible adiabatic expansion process, so this becomes dryness fraction becomes again it will be down, means it becomes moisture, have steam have some moisture, so that becomes 0.86. Okay, so this is about the problem number 3. So we have solved this problem. So let us we are moved to the next problem, where we can understand in different problems for numericals. Okay, so I hope you understood this problem. We'll wind up this video and move on to the next problem. Thank you.